uh, SLP, right? Single layer perceptron. I hope you all understood what a single layer perceptron is. So in the single layer perceptron, we'll be having only one perceptron will be there. And perceptron is like, we can compare the perceptron as a neuron we have in the brain. All this thing we discussed in the previous class. And this perceptron, which is the neuron, which is like we are simulating the neuron in our biological neuron is simulated with this perceptron. And this perceptron is called as computational unit. And you also know each and every computational unit will be doing two functionality. One is summation, and the output which we get from the summation will be given as an input to the activation function. The output which we get out of the activation function is the output. So that is what we learned in single layer perceptron. And we know single layer perceptron is applicable for binary classification and it should be linearly separable. Then only we can apply the single layer perceptron. But in real time, every time we won't have the problems in that kind, right? We may not always have the problem that could able to linearly separate these two classes. It will not be like that. We are moving to the next one. Another algorithm in the artificial neural network is multi-layer perceptron or multiple layer perceptron. So from this word itself, you can understand there will be more than one perceptron available. So in single layer perceptron, we call it a single layer because we have only one perceptron available. But in multiple layer perceptron, in the word itself we say that multiple, and also it's a multiple layers also there for the perceptrons. So how does this multiple layer perceptron looking like? So if you remember the single layer perceptron, we'll be having an input node. So we'll be having some input node that will be directly connected to the perceptron, and the output what we get out of is the output. So we have only one perceptron available here, which will be doing summation as well as the activation function. But if you see in multiple layer perceptron, we have input layer and the output layer. In between the input layer and the output layer, we'll be having one or more number of hidden layer. So how the structure is looking like, for example, if you think that I have some two input layers, this is the input layer, and I'm going to pass some two attributes over here, and this is the input layer, and that will be connected to a hidden layer, maybe like this. This is the hidden layer, and I can have more than one hidden layer. Finally, I'll be connecting this to an output layer where we'll be getting the output. So it is not like only one output should be there. You can have more than one nodes perceptron in the output layer as well. So how does this look like? This input will be given to this both perceptron, and this input will also be given to the both the perceptron. So for example, this is x1 attribute, this is x2 attribute. So this is a hidden layer, we'll say this hidden layer, hidden node 3, 4, and then this output which we get out of this hidden node H3 will again be passed to this two output layers nodes, and this can be like output 5, some name I am giving, okay, output 6. So, and this again will be connected like this. So, and finally we'll be getting some output here. So that will be our output. So here, so as usual, you should not forget if it's a perceptron, always all the perceptron will be having two functionality that is not changing here in the multiple layer perceptron also. First you will do the summation and then you will apply it to the activation function. So we learned already, if the activation function is given, and then you can use the activation function, otherwise we'll be using threshold value. So we already learned how to have an activation function, how to use with an activation function. Also we have learned how to use with the threshold. Okay, and then here also, so this is the input which we, for example, in the data set, we will be taking the output, input. That input is passed through this input layer. So this can be a first attribute, saying the height of a person and the weight of the person. So height may be one attribute, weight may be another attribute. So these are the input value from the database data set, which we will be giving as an input to the hidden layers. And it is also not restricted that there should be one hidden layer. You can have more than one hidden layer. That is why we say a multiple layer perceptron. And then, as usual, which we saw there in single layer perceptron, every input will be attached with a weight. And we know the importance of the weight. Weight says how well your input impacting the output. So this will be having a weight of 1 3, which means for this, and to denote this from where to where it is going, or you can just say W1, W2, W3, W4. And this again. So this we do a summation and we'll be applying an activation function. Here we'll be getting an output, right? Say for example, this is the first output we are getting and this is the second output we are getting out of this. So, and this output is the input for the next node. And here this is also will be having some weight. This also, everything will be attached with the weight. This output which we get from here will be given as an input to this as well. Here also this will be having a weight. This also will be having a weight. Right, so the input from the data set will be given, passed through this input layer to the hidden layer, and every input values are attached with every attributes are attached with a weight, and finding a summation, giving it to the activation layer, will be getting an output, and that will become an input to the next perceptron or computational unit that is attached with the weight. And this output is also given as an input to this perceptron attached with the weight. And the output which we get out of this perceptron or a computational unit will also be given as an input to this output unit with the attached weight, and similarly this. Finally, we will be getting output y1, already y3 and y4. And then what will you do? So this is what generally we'll say as multiple layer perceptron. In multiple layer perceptron, another important thing is, another significant event here we do is, one is forward feed. What we said now is forward feed. From the input layer, we'll be doing attaching the weight, finding the summation, given to the activation function. This output is again given as an input to the output layer. Finally, finding the summation, applying to the activation layer, we'll be getting an output. So that is a predictor output, right? So this step is called as forward feed, or feed forward. The next one is, the after we get a output, generally in here also in single layer perceptron, once we get a output, what will you do? We will be calculating the error. Based on the error, we will be going back and updating the weight. That's what we learn in single layer perceptron. Same thing we can also do in multiple layer perceptron also. So again, here what will I do? We may be having an actual value for it. For example, actual value for this is the 0.6. But maybe after we do the calculation, the predicted value is 0.8. We know that we'll be finding the difference between, based on this error, we'll be going back and updating the weight, and then we'll be updating the weight. And again, we may be having the expected output of this is 0.4, but we may getting it as 0.7. So again, there is an error. So what we'll do? We again backtrack, go back and update this weight, who are all related to output. For all this weight will be updated. This weight will be updated. This weight again, after updating, will come back, and again we'll be updating all the inputs who are related to get this output. So after we update this weight by doing a backward propagation, this is called as backward propagation. So reverse going through backward, and we will be updating the weight. Once we update the weight by using this backward propagation, again we will do the same forward feed forward, which means again we will be moving forward by doing the same step Again, we'll be calculating the error. If the error is reduced to a desired level, then we will be stopping it there itself. Otherwise, once again, we will be finding the error in that particular place, going back, updating the weight, again going back, updating the weight, again we'll do this until we could able to reduce the error in the output layer. So this is what we've done in the multiple layer perceptron. The basic, I hope you got it, of multiple layer perceptron. So we know that we already have learned the algorithm of single layer perceptron, how to do the single layer perceptron. First we should know what is the input, and then what we should know what is the weight. Sometimes bias will be added. In this case, we are not going to consider the bias. Sometimes you, as I have told, three different ways of having a bias, not having bias, or bias with the weight. But in this case, we are not having bias. Then after having all this input value and the weight, we will be doing the computational unit. After there, we will be doing summation, applying to the activation function, then getting the output, calculating the error, going back and update the weight. And this can be again repeated for in number of times based upon the reduction in the error. Similarly, in the multiple layer perceptron also, we have an algorithm in the similar way, but here we have multiple layers with different many perceptrons. That's the only thing. So let us solve with a small problem so that you will be clear how we can proceed it with the multiple layer perceptron as well. So you can guess what will be the steps or the algorithm you can follow for this multiple layer perceptron. As usual, you did in the single layer perceptron. First, you have to think about the input layer. So in the this is our input layer, this is our hidden layer. Again, we have only one hidden layer, and this is the output layer. In the output layer, we have only one computational unit or only one perceptron, and we get only one output in this case. Okay, and here in the input layer we have two attribute x1 and x2, and the values of this is given here, and with each input some weight are attached. Initially we have taken some random value as a weight for this each input, and so first step is we should know what is your input and what is the weight. So that is what the first step is. We should know about the input, as well as we should want to know about the initial weight associated with the input attribute value. What is the second step we do? Then we have to apply it to the computational unit. In the computational unit, you have to do the summation, and then you have to give it to the activation function. This is what we'll do. And then we'll be calculating the error and backpropagate based on it. So same thing. So let us do it one by one. So first, initially now we know first step, that is we know what is the input. Also we know what is the weight. So now we are going to go for the forward, feed forward. Okay, feed forward step, that is the first step we are going to do. So what we are going to do is, let us calculate this one by one. And one more thing, summation, what to do for summation you already know. Here I am going to consider, this is what the formula for summation, okay? Weight, sum of all weight into the input. And then the activation function we are going to use here is a sigmoid activation function. We know, you know already about sigmoid, which we learned in logistic regression, if you remember, 1 by 1 plus e power minus aj. So the input which we got here is given here, which we got from this summation. Okay, so let us do it. So we want to calculate for this computational unit, also for this computational unit, then based upon the output which we get from here, and we have to complete for this as well. So as of now we have three computational units, our perceptron. For the three perceptron, you have to find what is the output. So let us take the output value as y3, y4 and y5. Okay. So first we will calculate the first summation. Let us take it as A1 for this first one. So so you know that for this hidden layer also we have two parts. One is summation and activation function. Here also summation and activation function. Here also summation, activation function we have, right? So first this summation let us find. Let me name it as A1. So how will you know, how will you do the summation? weight into input. So the weight there is we have 1.1 into x1 value is 0.35. Let me write the equation for one time. So I'll be writing weight of 13 into x1 plus what is the another input we are getting for this particular computation node is this one. Okay, so this is the second attribute. So the weight of that is W23 into the x2 attribute. So these are the two input we are getting for it. So if you apply the value plus this is one value and what is W23 is 0.8 into the second input is 0.9 and if you calculate it you will be getting an answer of 0.755. Okay, so you may thoroughly know what is single layer perceptron, but you should, as you know, machine learning, you should also know what is happening actually in the single multiple layer perceptron also, right? That is why I'm explaining this problem just to know what will actually happen there. Okay, so don't get scared of it. So now I completed this summation. After I complete this summation, what is the next thing? The output which we get out of the summation should be passed to this activation function. The activation function formula is this 1 by 1 plus e to the power minus aj. So here we'll be getting the output which we get here will be y3. So this output of this computational node, how will be getting is we have to apply this activation function f of a1. This input is given here and that is 1 by 1 plus e to the power minus a1. Here the value of summation is taken in a1. So which is equal to 1 by 1 plus e to the power minus 0.755. So if you calculate the value, you will be getting 0.68. Okay. So for this computational unit, for y3 we got the answer. So y3 is equal to 0.68. Now we found the output for this computational unit. Similarly, we have to do for this. Let's do it. So A2 is equal to what are the summation? Two inputs. One is coming from x1. So its weight is 0.4 and its input is 0.35. I hope you got it. So for this computational unit, this is the input we are getting and the weight is 0.4 into this input 0.35 plus one more input you are getting for this is the input is 0.9 and the weight is 0.6. So weight is 0.6 into the input is 0.9. If you calculate, you will get a value of 0.68. After getting it, the summation is done. What is the next part? We have to apply to the activation function. The value of activation function formula is this. So the output which we get out of it, we have given the name as y4. So I'll say y4 is equal to 1 by 1 plus e power minus a2. So I'll say 1 by 1 plus e power minus 0.68, right? Which I'll be getting as 0.6637. So now we got y4. The output of the second computation unit is 0.6637. Okay, so this is what the output which you get out of this. And then after doing this, we have to find for A3 as well. What is A3? The output of this computational unit. So what are the input of this computational unit? The output which we get out of this perceptron and this weight plus the output which we get out of this computational unit into its weight. So what is y3? So the output which we get out of this computational unit is y3. So its value is 0.68. Y3 is 0.68 into its weight, that is 0.3. This weight, okay? W35. So plus, and what is the another one input we are getting for this computational unit is plus the y4 is the output of this computation. That is the input for this, right? So y4 we got is 0.6637 into what is it weight we got 0.9. So that is 0.9. And if you calculate this, you will get an answer of 0.801. So this is only the first part, the summation, and then we have to apply to this activation function. So that is the output we get is W5. The output of the activation function itself the output. That is why Y5 is equal to 1 by, so 1 by 1 plus e power minus 0.801, right? So the value, the output for this is 0.69. Okay, so we completed the feed forward. Okay, so we've moved forward from the input layer to the output layer, and when we move forward, this is what the network output. This is what the output we get out of this neural network. This is what the output. Okay, now we completed, right? After we complete every time, we know already we learn. After you do every step, we do one feed forward, we have to see what is the error. Depending on the error, you have to backtrack and go and update the weight. So here to find, so actually the output which we got is 0.69, but the actual output is 0.5. So now you can find the error out of it. So how will you find the error? So we want to find the error. So the error is y target minus y5. So which means actual value minus predicted value. That is what generally we do. So we know what is the actual value given in the question is 0.5. So 0.5 minus, and the predicted value, that is y5, the output which we get out of this perceptron y5, we got a 0.69 minus 0.69. And when you find the difference, you will get as minus 0.19. So this is what the error value which we get after we do feed forward. Okay, or we do the forward pass. Two things, forward pass is there, backward pass is there. So now we completed the forward pass. Now what is the next thing, after we find the error, since there is an error, minus 0.19 error is there. So since error is there, we have to go back and update the weight. So how will you do weight updation? First we have to update this weight. After updating this weight, then go and update the other weight of this node. Similarly, first you have to update this weight. Based on this, you have to go back and update the other weight of this node. So let us see some examples, and the same thing you have to do for the rest. So if you see that, how will you update the weight? How will you update the weight is, this is what the formula. So first, okay, when we learn logistic regression, when we try to reduce the weight, we use gradient descent algorithm to reduce the weight. Same thing is here also. We are going to use that for reducing the error. So first we want to find delta Wj, Wji. This is the formula for it. And based on this new value, we'll be adding this new weight with the old weight, and we'll be updating the original weight. Okay, so first we have to calculate this delta weight. So that is, we should know whether to increment the weight or decrement the weight. So based on the gradient descent, we have already learned the U curve and all. Same thing here. So what are the different parameters we have here is, one is, this is learning rate, this is the error, and this is the output. Okay, so we are going to update the weight based on the learning rate, the error which we got, and also the output we got for it, because we are moving from the backward, right? So based on the output which we got, we have to do. And then we know what is learning rate. Learning rate is already given in the question. If you see here, learning rate here is given as 1. We know the importance of learning rate also, how fast or how to slow down the process. We know that. So learning rate is given. And what is the output we got also, we know, because we know what is y5, y3, y4 all we have calculated. Then what about this error? We want to calculate the error for this O5, H3 and H4. For every computational unit, we want to find the error of that particular perceptron or the computational unit. Based on that only, we can able to update this weight. Okay, so if it is an output node, this is an output node. If it is an output node, to find the error is this formula. Okay, the output into 1 minus output value into the target value minus the output value. That if it is for the output unit, the output layer. And if it is a hidden node, if the computational unit for which we are going to find the error is a hidden node, then this is the formula. Similar to this, but here if you have more than one node, then we have to find here if the output node is more than one, then we have to find the summation of the error of this into the weight. Okay, so we'll see do calculation. So let us update this weight, and also we'll be seeing one weight here. Let us see an example, and also we'll update one weight here. Same thing you have to do for the rest, so that we'll get an updation. So let us do the back propagation here. I hope you got it. So we are going to do the back propagation. So first, for when you back propagation means what, we have to move from the last, which means from the output node or the output layer. So for first we are going to find the error for this perceptron, that is O5. Okay, so let us do that. For the output unit, we are going to find the error. We know if it is an output unit, this is the formula, and if it is a hidden node means this is a formula. So first we are going to find the error. Error is denoted by this delta for this node O5. So for that is denoted as delta 5. That is the error. Okay. For O5 node only we are going to find the error. So I'm going to denote as delta 5. So that is what error here denoting. This value denotes the error. That is what we are going to find. So since it is an output unit, then we have to use this formula to calculate it. So how will I calculate this? According to the formula, OJ means it is the output. What is the output there is Y, the output value. Then 1 minus Y. Then what is that? Target minus OJ, the same thing. So Y target minus this Y value. So when you apply it, what is the Y we got for this? That is Y5. What we got for Y5? That is the output which we got, right? That is the output for this particular node. For this particular node, the output is Y5. What we got is 0.69. So I'll put 0.69 into 1 minus 0.69. What is the target actually? The target which we got actually is 0.5. So we have to apply that. So the target is 0.5 minus 0.69, the value. So you will get minus 0.0406. So this is the value which will be you will be getting. So for this particular node, we found the error. Same thing, we want to, so if I want to update the weight, for this node I have to find what is the error. For this node also I want to find the error. So now we are going to find the error for hidden units or hidden nodes. For hidden unit, the formula is different. So let us calculate for this node first. So it is H3. So let me denote it as delta 3 is equal to, what is the formula? You can see here. This is what the formula, output into 1 minus output into delta value, which means the error of the value which is coming from backward, and its weight. Let's do that. So what is the output here? OJ is output. So what is the output which we got here is this one, right? Y3 for this particular node. So when we calculated this, the Y value which took is Y5 we took. But when we calculate for this node, the output of this node is Y3. So we have to take that. So I have to say Y3. Here we took Y5. If you are confused, you can write like this, Y5. Here it is Y5 into 1 minus, Y3. So that is the output of this node, because we are going to find the error of this. And into, then what you have to find? The delta as well as the weight. What is delta? The error. So what is the error which we got for the previous node of it? The error which we got is 0.0406. So that is the error which we got for this previous node of this. So that is the error. So we'll say minus 0.0406 into weight. What is the weight for this? That is this weight. Because we are coming from backward, right? So based on this we are going to do. So the output of this node is y3, and then the error we have to calculate, which we found as of now is this one. So that error into this weight. So 0. So if I write the equation, it will be like into W35, the weight into delta 5. So if you substitute the values, Y3, what is the Y3 value? The output which we got for Y3. It is 0.68. So we'll be putting 0.68 into 1 minus 0.68 into 35, which means this weight, okay, because we are coming from backward, and based on that we are rectifying it, and so the weight for this is 0.3 into the error which we got for this particular node is minus 0.0406. So if you calculate this, you will get the answer as minus 0.00265. Okay, so this is what the error in delta 3. Okay, so here we found for delta 5. Okay, what is the next error we want to find for this node? So we found the error for this node, we found the error for this node. Now we want to find the error for this node. I hope now you can write it. So for that we will represent as delta 4. So for delta 4, what is the output? So for this delta 4, the output which we got for is y4. So we'll write as y4 into 1 minus y4 into, for this node we have to take this weight, right? So I have to say w45 into the error which we got for this, same thing. So that is delta 5, which is equal to y4. What is y4 we got? Y4 is 0.6637. So it is 0.6637 into 1 minus 0.6637 into, what is the weight we have is 0.9, this weight. So 0.9 into the error of this previous computational unit. So that unit is this one, right? Delta 5. So that is minus 0.0406. And if you calculate this value, you will get minus 0.0082. Okay, so this is how we will be calculating the error for each and every computational unit. Now we found the error. So what we found is this delta value we found. If it is a output unit, we know this is the formula. And if the delta, the weight we are finding is for the hidden layer, this is the formula. So based on that, for each of this computational unit, we calculate this delta value. So now already we know what is learning rate, we know what is delta, now we found it, we know what is the output. So now we are going to calculate the new weight. Okay, we are calculating the delta weight. Based on that, we will be adjusting the original weight, right? So depending on the gradient adjustment, we want to say whether we want to increase, decrease on. So based on that, we will be getting the delta value. After seeing the delta value, we will be updating the original weight. So what is the formula for this is to compute the new weight. So to compute new weight, so what we are going to do is, we want to find delta of Wji is equal to, we want to find the learning rate, and then we want to find the delta of J, that is the error, and also we want to find the output of it. So using this formula, let us calculate it. First, we are going to update this weight. Okay, let us update this weight. Directly we cannot go and update this weight. First we will be updating this weight. or you can update this weight anything. As of now, we are going to do it for this W45. This weight we are going to update, and then we will update any one of the weight of this. We'll update this weight as well. So based on this formula, let us do it for delta of W. We are going to apply for 4, 5. Okay, that is this weight. 4, 5 means this weight. So let us update it. So what is the formula? That is learning rate already given in the question, and error. So for which error we should take is error of 5. Okay, and then what is the which output we have to take is y4. So this error into this output, that is y4. That is what we have to take. So if you see in the question, already learning rate is already given in the question. The learning rate given in the question is 1. So based on that, when you apply for it, learning rate is 1. 1 into the error delta phi is already computed here. It is this one. Minus 0.0406 into y output of this particular node, because this weight only we are calculating. So we took the error from there and the output from there. So that is y4. What is y4? It is 0.6637. So 0.6637. So when you calculate it, you will get a value of minus 0.0269. So this is what the value which you will get for delta of W45. So now this using this delta value, we are going to adjust the actual this weight W45's new weight. So now we are going to adjust W45's new weight. So how to update this is, first you have to add delta of W45 plus its old weight. Okay, whose 45 is old weight. So delta 45, you know, minus 0.0269 plus what is the old weight actually? Old weight of this is 0.9. So the value is 0.9. So W45, the answer you will get is 0.8731. So the newly updated weight for W45 is, we got a new weight. So for one step here, we found how to update this new weight. Similarly, I'll tell you, I'm not going to say for every weight, same thing you have to do for this as well. Now let us update any one of the weight here. As of now, let us take this one. So we have to take the error from here and input from here, that's it, into learning rate. For that you have to, that is the delta. Based on the delta, you have to update delta value plus this old value will give you the new weight. So how will you calculate? So weight of delta of weight of 1,4, right? 1,4. 1,4 is equal to, so how we have to calculate is, first you have to put the learning rate into, and then you have to, according to the formula, then you have to put the error. So which one you want to find the error? That the error of this node. Okay, the error. So previously we took the error of this and output of this. Similarly, for this weight, we have checked the error from here and the input from here. The input is 0.35. So that is error of 4 into input of x1, and which is equal to 1 into, what is error of 4? Error of 4 which we have calculated here is this, minus 0.0082. Minus 0.0082 into, what is the input value of this? So if you see in the input, the value is 0.35. So 0.35. So if you calculate it, you will get the answer as 0.00287. So now we found the delta W14. So now we have to find the weight of 14's new value, which is equal to delta of W14 plus W14's old weight. So the delta value is 0.00287 plus what is its old weight? You see the old weight is 0.4. So the 0.4. So you will get the answer as 0.3971. So the new weight for this is this one. So you can see here. For this one, this is the new weight we found 0.39, and for this one, we found this. So W45's answer is this one 0.8731, and for this also W14 also we found it. Similarly, you have to do for all the others. So you have to do it for 0.21 for 3,5C, for I and JS3, for the W35, same thing you have to find Wij delta value, input value, and learning rate is same for that. Using that, we know what is the value for 35. So 0.2724. Similarly for 1 and 3. So this one, the updated weight is 0.0991. So that is here. And for 2, 3, the updated weight is 0.79. And for this one, 2, 4, then updated weight is 0.5926. So one step we have done. So we know what is I value, J value, and weight is already available, old weight. So if you see for 4, 5, what is the already available old weight? 0.9. So that is here. And then this is the error value which we found. You can see the error value. This 4, 5, we took this value 0.046, that is what here. And what is the input for that? From Y4, so here 0.6637, so that is here, and the learning rate. So this step we completely did. For this 4, 5, we completely did it. Similarly for 1, 4 also we did it. So 1, 4 also we did it. So we know what is the weight, old weight, and this is the error which we found, and this is the input value, this is the learning rate. Similarly, in the same way, when you do for all the other weights, you have to do for this weight in the same manner, this weight in the same manner. For all this weight you do, you will get this table, and that updated based on that back propagation, the weights have been updated here. Okay, so now we did it. So once feed forward is done, and also we did one back propagation also done. After doing this back propagation, you can go for the next epoch. Okay, so what will you do again? Same thing you have to do again and again. So what will you do again? You have to find the A1 value with its new weight. How will you find a new weight? So your input is 0.35 into your updated weight is 0.0991 plus your input is 0.9 into your updated weight is 0.7976. And if you calculate, you will get a value of 0.7525. And when you apply to the activation function, this y3, you will get, it is 1 by 1 plus e to the power minus 0.7525. You will get 0.6797. So this is what the value you will get. Okay, so because after you update the weight, you will get new output. So this is what the previous output. After we update the weight, this is what the new output. And the same way you have to do for A2. If you do for A2, you will get 0. How will you do for A2 for this node? So what are the inputs? 0.35 into the weight of this is 0.3971 plus next one is this is the input given 0.9 into this value. So 0.9 into 0.5926. So which you will get as 0.6723. When you apply it for Y4, you will get a new value of 0.6620. Similarly for this node. Now for this node again we got a new output and a new weight. Here also you got a new output and a new weight. do this output node. So that is A3. So A3's our input is 0.6797. So this is the one input. What is its updated weight? 0.2724 into 0.2724, which you will be getting. Sorry. Then plus one more thing you are getting from this output and this one. So that is 0.6620 into what is it weight? 0.8731. So when you do it, you will get 0.7031. And then when you apply it for activation function, that is Wi-Fi, you will get 0.6820. So this is the new output value which we got, Wi-Fi. This is the output which we will be getting for this. Okay, and now again, actually, what is the actual value output? Actual output value is 0.5. So if you calculate it, again, if you calculate 0. If you find the error, so the actual value is 0.5 and the predicted value, Y value which you got is this. So again, if you find the error, no. So you will get a error value here, right? So based on this error, again, once again, since we have error, once again you have to go backward, update the weight until you are satisfying with the output, or until once it reach here, you have to iterate this again and again. So previously, if you see the Y3 value which we got, is 0.69. Now after you do for the second time, it is 0.68. So that is what little bit improvement we got. Similarly, you have to do for many times for you can do until you are satisfied with the output. You can repeat it. You can do feed forward and again back propagation feed forward. You can do for certain epochs, and once you are satisfied with it, you can stop it so that you will be getting the perfect weight. Okay, I hope you got it. How to do this is about multiple layer perceptron, and the rest of this we will be discussing later. That is, we almost discuss everything. Now you know what is the difference between single layer perceptron and multiple layer perceptron. I hope you got all these things.